Thank you for joining today. As the topic says, I'll be talking about SQL Server specifically and how to run it effectively and efficiently on Azure VMs. Just to set some context, this is more a SQL Server session than an Azure or a VM session. So I assume some of you have familiarity with some of the basic concepts of Azure in terms of storage and networking. If not, I have resources at the end of the deck, or we can chat later after. I'm free pretty much after this session. Just to introduce myself, my name is AJ Jagannathan. I'm a lead program manager in Microsoft. I lead the Tiger team in the database systems group. I've been with SQL for 18 years now, about 9 releases, starting with SQL Server 6.5. You can reach our team at Twitter through MS SQL Tiger or me through my alias there. Definitely reach out, and if you have any questions, I can stay back and answer them. I have about 6 demos, so I'll see if I can get through all of those, but definitely useful stuff. So in terms of agenda, we will talk a little bit about high-level overview of the data estate for Microsoft and how SQL Server has evolved here. Then we will focus most of the session on SQL Server on Azure VM specifically, and what are the important things you need to consider, especially if you are looking to run tier 1 workloads. The main aspects you will be worried about are performance, security, high availability, the core fundamentals, and also protecting your data. So we will talk about some of these best practices, as well as we'll also show a couple of new things. One, how do you migrate seamlessly to Azure VMs, as well as protecting your data through an enterprise backup solution that is in the works. That's still in preview. If you have questions, feel free to use the mic, or I'll try to repeat it here because it's recorded, so the recording captures it. In terms of the Microsoft Data Platform, you may have seen this or heard this. One of the goals of SQL Server, in fact, starting with 2016, is to make sure the platform is the same no matter where you are, whether you're running SQL Server on-premise, on the cloud as a PaaS service like SQL DB, or on VM. You want to have the same experience in terms of features so that your applications continue to work, whatever it is. And you want to leverage the same capabilities that you expect on-premise in terms of, say, you're upgrading or migrating to SQL Server on-premise. We want to give you the same experience when you move to the cloud, as well as high availability using always on. How do you do that? And also, once you're in Azure, it gives you other benefits, like you can scale out by using various VM scale sets and VM scale out technologies. So you can scale out your read workloads using secondary replicas. This really enables you to do business analytics, offloading it from your transactional environments, as well as you can do even hybrid. So you can have a mixture of SQL Server running on-premise and a replica running in the cloud, and we will talk a little bit about that. And finally, we will touch some on backup and restore and some of the new services that are in the works for you to do enterprise-level backups of your databases. So if you look at the data platform itself, we have many different offerings for both the database engine for the OLTP workloads, as well as the data warehouse. Our focus today will be specifically on the middle left, the one in red, SQL Server and Azure VMs. But one of the things is, as I mentioned in the previous slide, is because of the way we have built SQL Server, it runs on a single code base, whether you're using SQL database as a PaaS service, or SQL Server on-premise, or the VM. The actual engine that runs in all these flavors is the same code. The entire engineering for SQL Server is done from the same source branch, and the developers check into that branch, and then it ships in different vehicles. And a lot of the features that you see on-premise today is already available in the cloud. And once we accumulate a set of features, then we release it as on-prem and also as gallery images. So, which will give you a consistent experience if you are running on any platform. And all your tools will continue to work. You can use tools like Management Studio or SSDT, etc., either for on-premise SQL Server or for Azure database or Azure VMs. So this gives you a very good flexibility in terms of choosing your platform depending on the application need. If you really need to stay on-premise, you can. But if you want to leverage the savings from a CapEx and OpEx perspective and not worry about managing the database server environments and just focus on the applications, you can move to the VMs or the database as a service. So what is an Azure Virtual Machine? So this is a high-level block diagram, if you will, of how an Azure Virtual Machine looks. From the top, if you go from the top is where it could be an on-premise server or your users connecting from their devices, either desktops or laptops or phones. And then all the connections go through the virtual network to what's called a load balancer. Connections coming from external go to what's called an external load balancer. But if you're connecting internally within Azure resources, we will use the internal load balancer to move the connection to the right source target. And one key aspect when you're coming from on-premise to Azure is compute and storage are separated, which means today when you have a VM, most likely you could have disks attached to the VM itself. In this case, it's different. As you can see at the lower layer, the VM has only the compute and a local disk for the OS, whereas all the extra disks, like your data disks, are separately stored in a blob store, and then they're attached when you create the VM itself. You specify the storage account and all that information. And anytime the VM needs to communicate to the network, to the storage, it uses operations to the storage and then interacts through the API layer in that form. Now, what are the options that you have if you have to go run SQL Server on Azure VM? We have many flavors of gallery images. We have images starting with SQL 2008 and up. If you have applications which are really old and legacy and you don't have a time to now recertify a new version, you can still continue using it and offload it to Azure VM. And we also will make available 2017 gallery images for Linux OS. 2017 was announced earlier this week. So this should be available sometime early next week is what we heard. So you can also use that. And you have all editions that you would expect on premise. So from Express all the way to enterprise editions of SQL Server and various platforms from 2008 R2 OS to all the way to 2016 OS, as well as the Linux messages. In terms of licensing, very flexible, two main options. If you can do either pay as you go, if you want to pay only based on consumption, or you can also license based on number of cores and edition. You can also bring your own license, and we provide two options. You can bring your own license key and transfer it to the VM, or we also give you license mobility. If you want to switch your physical license into the Azure credits, you can also do that through license mobility. Once in the portal, if you do the basic installation, it shouldn't take more than 10 minutes. It's really quick. And once it's created, you can connect with any number of client tools and drivers. You can RDP into the machine, and we support various types of drivers, as well as various types of tools, like the portal itself, Management Studio I mentioned, PowerShell, as well as various operational tools like System Center, etc. We'll look at some of these examples. In case you didn't know, both developer and Express editions are free, starting with SQL 2016. You don't need to have a license key to use developer edition. And the other big change we made starting with 2016 SP1 is a lot of the features which were enterprise only for the programming area, like for example, column store or in-memory, etc., are now available in all editions. The main differentiation for standard versus enterprise is performance, high availability, and security. So if you write an application, previously you had to worry about what target platform it is, whether it's enterprise or standard, and then you may or may not be able to use features, but that restriction is removed for the most part. And we also refresh the images in the gallery every time we release some critical updates or we release service packs or cumulative updates. In terms of VM sizes, again, a lot of options. For SQL Server, specifically, since we are focused on that in this session, we recommend using DS series or higher because this gives you a local SSD storage. And in addition, we recommend using premium storage. We will talk about why and also show you some performance differences. In addition to that, if you really have a more intense workload, we introduced the GS series, which has a much faster processor, a lot more cores and memory. And this table, I have a hyperlink on this slide, but you can look at it at the bottom that it gives you really much higher number of IOPS as well as you can go up to 32 cores and 448 gig in memory. Does anyone need more than this? Or are you using any environment which needs more than this many cores and memory? Okay, I have an answer for you. So, yeah, you can go to the link. So what we introduced is called memory optimized VMs. So at the very bottom you can see M series. I know it's a lot of numbers on this chart. If you look at the very last line, we have up to 128 cores and 4 terabytes of RAM. And this is really, really fast. Think of it like a beast. It's pretty much comparable to your on-premise data center for if you're running like, for example, in-memory or column store type workloads. This will give you that capability to scale up on a single VM to that many things. Or if you want to do a consolidation, you can put many instances on a single VM of this size. Yeah, question? So the question is 4 terabytes as the max. For that specific SKU, it is. But considering that we are keeping up with hardware evolution, don't be surprised if it goes up in the future releases. But this is the highest available for SQL Server at this. And we even have a special SKU in case you have noticed, if any of you are using SAP HANA, there are SAP HANA VMs also available, which also uses one of these big configurations where you need extreme low latency, a lot of memory and a lot of cores. In terms of VM availability, so this is more a VM concept, but you can definitely leverage it for SQL Server. You can create what is called an availability set. What availability set provides you is you can create kind of for your compute, not for the storage. We'll get to the database part later. Let's say you have many VMs you want to have for fault tolerance. So you can put them together in what's called an availability set. And once you create an availability set, let's say you have 3 VMs in your availability set, what Microsoft will ensure is these VMs are in separate fault domains and upgrade domains. What do I mean by that? By fault domains, we will ensure that these VMs do not share any underlying resources. So if there's a failure of some storage, for example, it will not affect all the VMs. It will impact only one VM which is assigned to that. An upgrade domain basically ensures that all the VMs are not patched at the same time. So you will always have availability of VMs for your application so that you don't have any downtime and all the VMs go down at the same time to do patching. And then we also have managed disks. So this was something that was introduced a few months back. So in the past, you had to create storage account, and storage accounts had limit on the IOPS, and then you had to create many storage accounts if you wanted to increase IOPS. And then if you had many VMs and you're basically expanding, it becomes a nightmare to manage a combination of storage accounts, VMs, and especially with introduction of VM scale sets where you can dynamically scale up to thousands of VMs. We introduced what's called managed disks. So you don't need to create a storage account anymore. When you create the provision, the VM, you can say, I want to manage disks. And Azure and the backend will take care of managing the disks. By this, what it means is you can actually use a single managed disk configuration to scale up to 10,000 VMs. And you can have, like, I don't even know the number, but thousands of IOPS because all of them are managed in the backend for you. You don't have to worry about it. And it also makes migration easy. If you're moving from, let's say you started with a standard disk and you want to move to a premium disk, in case of unmanaged disks or storage accounts, you will have to stop the VM and then copy the image and then restart the VM and attach it back. So you can avoid all that confusion by making it seamless to migrate from standard to premium disks. And it also provides, for SQL Server, it provides another layer of security if you're also using always on and high availability scenarios. It makes it easier for you. So this is a diagram that I mentioned briefly earlier about fault domain and upgrade domain. It makes sure that for fault domain, we make sure that your VMs, if you create multiple VMs, we don't put it on the same rack in your data center. So if the rack goes down, it doesn't take out your, or if there's a disaster, we put it in different racks. And similarly for virtual machines, if you have to do some firmware upgrade on the rack, we don't take out all the VMs. So if they're in different update domains, we will only patch one rack at a time and we'll ensure the availability. So specifically, now let's talk about a couple of scenarios for, in terms of tier 1, what is important for high availability. So I have a link in the notes section which you can take a look at. The first thing is we do recommend provisioning a data center, a domain controller replica in a separate availability set than your SQL Server VMs. This is basically to make sure you avoid any latency or downtime between these two. Having a domain controller in the cloud helps. You can join it to the same domain as your on-premise, but to avoid round trips to on-premise, if you're using hybrid scenarios, keep a secondary domain controller in the cloud and put in a separate availability set so that there's high availability for the domain controller itself. And then if you're configuring always on or cluster, one of the things we want you to do is relax the ping, basically your subnet delay and subnet threshold. I have the default value and the relaxed values. So the subnet delay is basically how often the heartbeats are checked, and then the subnet threshold is basically number of heartbeats that fail before a failover is initiated. So the reason we recommend relaxing this is in Azure, if in case there are some intermittent network glitches, you don't want to have some false positives or intermittent network pings causing failovers. So by relaxing this, it'll take care of any noisy failures, and then it will not fail the VM just because there was a network glitch. And configure cluster to ignore storage. This is very important for database because there is no concept of shared storage in VMs for high availability. We recommend using always on, and I'll get to that in a bit. And basically what that will do is we will ensure that the databases are moved in a different way, because unlike other applications, database applications like SQL Server rely on write-ahead logging and other concepts. So I will talk about it in the next slide or two. We recommend not using we're basically specifying the no storage option when you set up the cluster. And finally, if you're using always on, you will need to, if you need to create a listener for failover so that your applications can failover without knowing the physical name of the VM, you will need to create an Azure load balancer where you will register the listener, IP address of the listener. So this load balancer will ensure that the listener connects to the right primary replica. The second thing you will need to do is also create a backend pool. Backend pool is basically, think of it as a logical group of VMs which are part of your availability group. And full details are there in the notes section on how to do this. And MSDN documentation walks you through with screenshots step by step on how to set it up. And you will basically ensure that by creating the listener on the backend pool, the listener will connect to the primary replica in the backend pool, and if there's a failure, it'll go to the next replica in the backend pool. Here's an example of one of the configurations. We do have hybrid capabilities with always on, which means you can have a primary replica on premise on your data center, and for DR, you can put a secondary replica in the cloud. And you can also use the secondary replica for read workloads. Or you can flip it over and do it the other way around. You can keep, if you decide to migrate to cloud, you can actually do a failover. Now your cloud becomes your primary replica, and your on-premise becomes your secondary, and you can point your workload now to the primary. So you can do different combinations of this. So we really give you full capabilities to flex this. And typical HADR scenarios, you can have 2 VMs on the same region, and then for disaster, you can create and you create an availability group across those. And if you want to create a different VM for disaster recovery in a different Azure region, you can do that within the United States or in some other country across the world. So you can extend your thing. You can also set up the listener, like I mentioned in the previous slide, where you can connect to your primary replica, and then when there's a failover, it goes to the second VM, and if the whole data center where both the VMs are down, it then fails over to the disaster zone. Now, we also provide some lot of automatic configurations which you can enable when you configure the VM itself. So let's talk about a couple of those. First one is we actually allow you to, let's see if this the light doesn't work, so I hope you're able to read that screenshot. So this is basically storage configuration. So when you go to the portal wizard, if you just pick your SQL Server image from the gallery, it's actually optimized for SQL Server workloads. So as you can see at the bottom, there are 3 drop-downs that it gives you, whether you want it for general workloads, OLTP, or data warehousing. This way, we'll pick the right configuration for you. And also, the VHD also has some best practices burnt into the gallery image itself, like, for example, some trace flags and some performance settings, which I'll talk about later. If you're bringing your own custom image from your on-premise, you will not have this flexibility, but I brought it up here so that you're aware of this. So in case you get manually, you can set these same things. And I'll show you a PowerShell script which you can use to do something like that. The second thing is automatic patching and shutdown. So you can also enable, if you want to take away the burden of having to manually go on, if you're managing hundreds of VMs, you can enable this and set a schedule. Hey, when do you want to automatically patch the VMs, and Azure will take care of it for you. Auto shutdown. This is another recently added feature, very new and very useful. So one of the biggest things is before you actually move your production to Azure, one of the things you want to do is do dev test and make sure Azure is the right thing for you. And a lot of times developers or testers may forget and leave the VM on, and you'll start getting heavy builds. So you can actually set up auto shutdown at a scheduled time, and if the VM will automatically shut down so you're not using any resources. So this is really useful in case of dev test scenarios, not on production. And finally, SQL Server also, we have automated backups. So you can set up schedule on what kind of backups, including compression, encryption. And it also protects system DBs now, not just user databases. And you can specify a schedule you want. So this is useful if you are managing few VMs. I will talk about an upcoming service later for enterprise backups, which will talk about managing backup and protecting your data for a large number of databases and VMs. And storage options. This is a busy slide. So Azure provides different types of storage. LRS, which is locally redundant storage, which basically keeps 3 copies of every disk locally on the same data center. But there is no resiliency, because if that data center fails, your whole storage is gone. You have then zone redundant storage, where you can have between 2 data centers in the same region or other regions. Then geo redundant storage. So this is basically distributing your storage. So you'll have 3 locally and 3 copies in the remote region that you specify. And you can also have RAGRS, or read access GRS. This is good for situations where you want to have readable capability on remote storage. So where you can, all your remote copies of the same storage will be readable. For SQL Server, however, we recommend not using this, any of the geo options. The reason being SQL Server uses write-ahead logging. I'm sure most of you are familiar with that concept. So anytime we have a change to data. We write the log record first before we write the data. So it is possible that with geo-redundant storage, there is latency because in the data storage, Azure storage does not know that it is a SQL Server database. So it is just moving physical blocks. So it is quite possible that your data file got replicated before the logs came in. So you will be out of sequence and you will have incorrect results and unexpected behavior for your application. So do not use redundant storage for your SQL Server database disks. So this slide talks about, as I was telling, how local redundant storage is. So for each disk, we keep 3 copies locally, and if you have availability set, we will also, and it's a managed disk, we will also ensure they are on different fault domains, so that if a disk fails on the rack, all the 3 copies will not fail. You will always have redundant copies available, and it has. You can also create resiliency settings like simple resiliency, which has no parity, or think of it like RAID 0. And you can also do mirroring and parity if you want to recover from the disks. And a lot of those are more useful for non-database applications. So as I mentioned, for databases, we recommend using always on for disaster purposes. And this goes into more details on how the disk itself recovers. We quorum all the writes to all the disks, all the copies, and we verify and make sure it's checksummed. And finally, so this is the 3 copies and 3 different fault domains so that none of them fail at the same time. So for SQL Server, we recommend premium storage because this really provides the performance you will expect from a database system or application in terms of, especially if you have I/O intensive workloads and you want extreme low latency. Premium storage uses solid state drives, and it provides up to 5,000 IOPS and less than 5 milliseconds of latency, but actually it's even more. You can create what is called storage pools and basically increase the number of IOPS across with striping, and I will show you an example later. It also provides local read cache. So anytime you pick premium storage, we also have another SSD cache on the VM itself. Remember I said the storage is remote from the VM, but we also keep a local read cache SSD where we can actually optimize your I/O because of this cache, and it provides extremely low latency of 1 millisecond or less. And all the communication that happens with the storage is reduced because we have a local cache. And these are some of the benchmarks from our internal testing. Backup to premium storage is 6 times faster than standard disks. Restore is 30 times faster. And write throughput is 2 times faster than regular SAN that you may be used to. The next aspect is how do you connect to the VMs? So there are many options. You can connect over the public internet. But if you're really into secure connections, you can do dedicated connections through what is called express route, and you can also set up a VM and use a listener, like I mentioned earlier, to connect to your primary transparently. And listeners, as I mentioned, you have to set up an Azure load balancer and register the listener there, and you will be able to connect. And internally, we will use an internal load balancer, so we don't have to go through public internet. And there are various providers that are listed here that provide this site-to-site internet connection. And if you really want a dedicated line to your VMs, that is also available through what's called express route. A complete list of providers globally is provided on the link on the top. So this will actually give you high bandwidth dedicated connection just for your company to Azure, and this is good for both applications coming from on-premise or even for hybrid scenarios where you want data centers spanning both on-premise and cloud. And we also do private peering if you have connecting between resources into the internally, so we don't have to go through the public endpoints. So with that, I'll show you a quick script in PowerShell through which you can automate. You can, for example, for SQL Server, if you have to do a mass scale deployments, you guys might be using something like sysprep images and configuration file with setup. So you can do something like that even with for Azure VMs through PowerShell. And as part of your Azure VM setup, you can also run custom extensions. So as part of the deployment, in addition to the base configuration of the VM in terms of storage and networking, etc., you can also do SQL extensions. So Azure provides custom extensions. So that will allow you to run SQL best practices on top of it. So when the VM is fully provisioned, you have all the SQL best practices, like for example, TempDB configuration, and if you have any specific max memory settings or parallelism settings, all that can be done as part of custom extensions. So I will not run the script because it will take forever to finish, but I'll walk you through some key steps, and I'll share the script. In this case, this is an interactive script, but you can hard code the values if you want specific values to be thing. So the first thing is I log into my Azure account, and then I get a list of all my subscriptions, and I prompt the user for what subscription you want to use, but you can hard code this if you have only one subscription for your specific offering. Then I go and ask if you want to create a resource group. So resource group is a logical container for all your resources for what VM you're creating, like networking, storage, SQL Server. It's a logical container, so it's, for example, let's say for application A, you want to put everything in one resource group and separate it that way. It's easy for you to manage it. So you can, once you create the resource group, the next thing you will do is storage. So in this example, I'm using storage accounts by calling the storage account API. But if you use manage disks, you can skip this step. As I mentioned earlier, you can use the option to just select manage disk. And then after that, it's straightforward. You just specify a name for your VM, what VM size you want. You can hard code these values again. Here I'm giving 5 choices for my users. And then I pick an image from the gallery and in the region and as well as the SKU. So all this can be automated. If you can have different scripts for different combinations, and you can actually create a web portal for easy deployment. A user just has to click and it'll go and do everything for you in the back end. And then the availability set I mentioned, so that you have redundant copies of VM for compute. So after that, it's basically the network, virtual network that you want to create. Again, it's very straightforward. You just ask a network name and the subnet. You can have one subnet or more than one subnet. We support both. And you create the virtual network. Finally, it comes down to creating the VM itself, which is basically the last API. So it's very straightforward. So this is all just the VM aspects. And in my folder here, I have custom scripts for SQL, like if I want to specify data locations, TCP settings, SQL configuration settings. You can actually, so Azure provides you what's called custom script extensions. So you can run additional scripts as part of your deployment. So when the VM is done, you have everything ready with all the best practices. So you can standardize your deployment best in that way. So that's a quick overview of the deployment itself. I will share this script, I'll upload the script, and you can also get, if you go to aka.ms/tiger toolbox, that's our GitHub repository, and you will find all tool scripts demos that our team does. We put it on there from any conference, any events, and even from other customer engagements. So in terms of, so next big aspect of VMs is security, right? In your data center, you have your own way to configure security, but what do we have in Azure? The first thing is we have physical security for the data center itself, which is monitored all the time, and it has very strict access control, so there is no concerns in terms of who's going into the data center, etc. Infrastructure security, we provide isolation of virtual networks for each deployment in their own private networks, and storage is encrypted as well as you can save your key now, bring your own key if you're using TD, etc., and you can put it in Azure Key Vault. And previously you could not bring your own key, but now you can do that. And then Azure itself has many certifications that comply with most industry regulations. A few of them are listed here. And finally, for SQL Server, all the basic stuff that you are used to using in terms of patching or encryption of database, as well as backups and connections, authentication, and some of the new features introduced in 2016, like always encrypted and row-level security, etc., are all available for Azure VM. So this whole landscape will give you a completely secure experience that you're used to on-premise. And as I mentioned, you can also use keys in your, you can bring your own keys that you're using and put it in the key vault and use that for encryption and decryption. I'll quickly show you another new feature in Azure, which is called Azure Security Center, which will allow you to monitor and look at some of the best practices for VMs. Okay. So when you go to the Azure portal, on the left side, you will, if you go down here, you'll see Security Center. And when you click on that, you'll see this dashboard. On the overview, you will see a lot of things like recommendations, security, any alerts. And then the red means there are some issues, green is good. For each specific component of the Azure that you're using across your entire subscription. This is not just your VM. So if you have many VMs in your subscription, you can see all of it. So let me go to the compute, which is where my VMs are. You can see here that the agent is missing in 10 of 145 VMs in terms of monitoring. What this means is to monitor your VMs, we need to install agents. So this is saying that 10 of the VMs don't have the agents installed. And if you go deep dive into that, it'll tell you which ones they are, and then you can go and address that. The other thing in the recommendations, it's saying like OS vulnerabilities. Maybe I'm not patched, because VMs is still, the patching responsibility is still, unless you have enabled auto patching, it's your own machine. You still are responsible for patching it. So this is a good way to know that, hey, something is not patched, so I need to make sure all my VMs are patched. If it's missing any system updates, that'll be called out here. This is taking a few seconds. Yeah, and you can see what critical updates need to be applied. The beauty of this is same as using like System Center in your enterprise for all the VMs, but it's freely available on the dashboard for your entire subscription. Now, if you go to VMs and computers, you can also see SQL-specific VMs, status, like if it is being monitored. Few of the VMs are not being monitored. If the endpoint is protected, basically if your public or private endpoints are secure or not, and if there are any vulnerabilities, and if you have enabled disk encryption. So this gives you a good overview of your landscape and a good way to quickly know, and you can set up notifications and alerts and to your email or whatever way you want to get it, and you will be able to do that. In addition to that, another new feature that was enabled is just-in-time access. So this one, I don't have it on this subscription. So this provides two benefits. If you don't want to have the VM access to your users all the time, you can set up schedules and you can give role-based access control to these VMs here. And the second scenario where this really helps is if there is a ransomware type attack and you want to really shut down the port quickly, you can come here and shut it down, so it will block, at the endpoint itself, it will block all connections. So this is useful for both scenarios. Just search for just-in-time access, or if you go to the portal, you can click on this link and it'll give you more details on how to enable this. So that's the security. So let's go back to the configuration again. So here we'll talk specifically for SQL Server. As I mentioned, use DS series or higher. You can go all the way to M series depending on your workload patterns. And for storage, make sure the storage account is in the same region as your VM to avoid any latencies. Do not put VM and your let's say the VM is in the West US region and the storage account is in the East US region. Keep them in the same region. And storage accounts have limitations on number of IOPS, which are, as I mentioned earlier. So you can create storage pools. So you can basically combine a bunch of VMs. This is similar to storage spaces that Windows 2016 introduced. And you can increase the throughput that way. And for SQL Server, enable read caching. Do not use the system drive for databases. Use premium storage, as I mentioned. And put data and log files in separate drives because of I/O patterns differences. And TempDB also in its own drive. Same best practices as we typically say. And the allocation unit size is 64 kilobytes, which is same as one extent. And if you use our gallery images, and I showed you the drop down where you can pick the workload, and it'll automatically optimize these things for you if you're using going through that experience. Turn off geo-replication. I mentioned this again. If you're doing geo-replication for your storage, your data and log can be out of sync because they are not replicated as a single atomic unit. Each disk is replicated at its own frequency asynchronously. So your log and data may arrive at different times, and it'll break the SQL's fundamental transit ACID properties, and you will get unexpected behavior. In terms of PowerShell script, if you're using, as you can see, the highlighted boxes, you can turn off resiliency to simple. As I mentioned, for SQL Server, recommended usage is always on. And number of columns, this is really important if you're using storage pools and combining many disks. Think of each column as a stripe. So number of columns should match the number of stripes. Let's say you have 16 disks that you have combined. Your number of columns will be 16. So we can stripe across each of these, and you can really get your IOP will basically 16 times. Let's say each disk gives you 500 IOPS. You get basically 8,000 IOPS because you're striping in parallel. If you don't do number of columns, the default is 1. The whole disk will be seen as one unit. So think of it as just one IO being issued at the time. So here we could do 16 parallel. And the second important thing is interleave. Interleave is basically the size of each write. So for SQL OLTP workloads, we recommend 64 kilobytes. And for data warehouse, 256 kilobytes. So the total stripe width will be 64K times 16 if you have 16 columns. Does this make sense? SQL Server configuration, this is a good reference slide. This is actually not just for VMs. We also recommend this for on-premise, and I'll show you a couple of demos. Instant file initialization. This is basically if you're creating really, really large databases. SQL Server by default has to zero out every page on disk. Let's say you have a terabyte size database, MDF file. We have to zero during create database each file, each page in the file. That can take forever depending on the speed of your disk. We have seen it take many hours, so a database will take a long time to come online. Also, if you have to auto grow, we will have to do the same thing. So, what this gives is, if your SQL Server startup account has a perform volume maintenance OS permission, we don't need to zero out. We will actually skip the zeroing it and set the whole file size on the disk, and then we will use the pages as needed. So your file, a terabyte file, will just be created instantly. And this doesn't apply to log files because for log files we will have to zero out, otherwise we won't know, since log is a circular file, we won't know where the end of log is. Enable locked pages in memory. So this is good in case you don't want your working set for your SQL Server to get trimmed due to some memory issues. And also it improves the speed of your memory allocations because we use a different API. Data page compression is basically useful for reducing your disk footprint. And with a smaller database file, because the pages are compressed, even your I/O is quick. Meaning, if it's compressed 10 times, then you're doing your I/O size is 10 times. Your packets are smaller, and your memory footprint is also small because the page is compressed. So you get a lot of benefits in terms of reducing latency. For Azure, the other good thing you can do is backup to URL. This is only useful if you're using only a couple of VMs, because we can actually do instant snapshot because the storage is already in the blob, and taking a backup of that is very quick. we can copy a backup of the very large file. It won't take many hours. It'll be almost instantaneous. And look up file snapshots and SQL backup to URL. It'll give you an example. It's similar to VSS on-premise, but it uses a different mechanism. And finally, other best practices, like I already mentioned, move your databases, separate them out. Do not use the OS drive for SQL Server databases. And read and write caching, turn off write caching, just enable read caching. If you want TempDB, if TempDB is very heavy I/O, put it on an SSD. If you use premium storage, you'll automatically get that, so it is very fast. And in every VM, you will also see what's called a D drive. It's about a terabyte size. Think of it that like a temporary drive. It's volatile, which means it will not survive restart of the VM. So do not put anything there. So I'll show you a quick demo of a couple of these best practices. So I'll show you. The first thing is, yeah, here we go. So this is basically a workload demo. What I'm doing here is, I have two scripts. Both of them do the exact same thing. In one, my database is on a standard disk, and in other, my database is on a premium disk. Exactly identical database, same schema, and the script runs the same workload. So as an example, we can see here. So basically what I do is I create a table, do about 10,000 inserts. I create a couple of other tables, and I do a bulk inserts and create cluster and column store index. Basically I'm simulating a lot of I/O, and we'll compare the difference between standard and premium disk. So I can kick it off from here. And I also track how much time it took into an execution statistics table. So let me go ahead and kick it off. So this is basically running a workload. So first starts with standard disk, and then this takes a couple of minutes. So while it's running, I already ran a couple of executions, so I can show you how my execution stats looks. Oops. So I hope you're able to read the screen. If not, let me see if I can. Actually, this will not give you a good. Okay, so the first row is premium disk and second row is standard disk. Ran it about 25 times, so the average is very reasonable. If you can look at the numbers here, you can see it's almost 25% faster. I mean, this is a very simple workload, but think of a real mission critical workload where you will see a huge difference. So every execution is almost 40 to 50 seconds faster, which is about 25% faster. So for SQL Server, you really want that throughput and latency, and this is using P30 disk. In fact, you can go up to higher P60 or higher, and you will get even faster throughput. And if you used, and this does not use striping or columns, so that will even give you more throughput than this number. The second demo I had was IFI and without IFI. So basically I turn off IFI and restore. Restore also creates the files, so you can see the same behavior. So in this case, I ran the restore without IFI, and you can see that at the bottom here, it took 2 minutes and 15 seconds. And I ran the same thing with IFI. It took only 45 seconds. So what I did then is, all my data is stored in this execution stats table. I quickly put together a chart in Excel. For the workload performance, you can see, as I mentioned, it's 25 times faster in premium disk. than your standard disk, as you can, let me make it here, as you can see from this graph. And in case of IFI, it's actually non-linear. It actually gets better and better as the file gets bigger. Say, for example, for a 1 gig file, it doesn't make a much difference because the database is not as big, so we can zero out very quickly. But for a 15 gig file, it's 46 seconds versus almost 4 minutes. And you can see the difference in how much time it took to create the file. And imagine if you have to go to a terabyte file, you will pretty much not see the y-axis for the IFI one. The other one will be maybe 10,000 times slower. So it's really important to have this setting turned on. Even for your on-premise systems, this will make a huge difference. Okay. All right, so let's go to, now we talked about a lot of some of these best practices. How do you bring the database to the cloud very easily? For VMs, we can bring it through many mechanisms. So we have invested a lot of things in data migration. You may have heard of some of these tools and things available, and even we have a booth on migration where you can see some of these. So we have built what's called a migration guide, which is a one-stop shop which will help you plan your migration. And we have built some migration tools and services, and let's quickly talk about those. The migration guide, the URL is at the bottom. It's a one-stop shop. You can pick any source and any target. It'll tell you both the business reasons, if you need to go talk to your management and tell them why we need to move to Azure VMs. It gives you a lot of that information. It has case studies, links to partners who can come and help you. And it gives you a workflow on how to go about the migration from a technical aspect also. So really useful, and it includes both SQL Server upgrades from older versions to newer versions or to the cloud. And it also includes foreign platform. Let's say you're moving from Oracle or DB2, etc., to SQL Server or SQL DB. It tells you how to go about and what are the options available. And there's a session I've listed on the top. It's right after this. Actually, it's at 11:15 in the same building, which will go more into this data migration specifically. So there are two tools available. One is Data Migration Assistant, which will basically assess your system and tell you all possible issues, feature recommendations, behavior changes. If you're moving from your existing source, whatever target you specify, it'll compare and see, hey, how will my database behave if I were to move to that version? So it'll give you a full report, and it'll also tell you how to fix it. It'll give you inline scripts to actually fix it and deploy the script also. So it's way better than the previous upgrade assistant you may have heard of. It's a completely different tool and experience. And then once you have done all your assessments and addressed your issues, you can use Azure Database Migration Service to move your databases. Again, this is a service which runs completely in the cloud, and it can be used, as I mentioned here, for foreign platform or SQL Server upgrades or migrations. If you have more questions and want to do the preview, there's a link there. Just send an email there, and the team will get back to you if you have any questions. And these are the different combinations that's supported, as I mentioned. The goal of this is to provide a seamless migration with minimal downtime, and you can do both multiple combinations of source target pairs as listed at the table below. Let me quickly show you one example of how to move an Azure VM from an on-premise database to an Azure VM. Okay. So basically, you have to create an instance of the database migration service. To save time, I've already done this. What this does is it creates a service in a VM. It's free. I mean, it's in Microsoft subscription, so you don't have to pay for it. And then what this service, all it does is it orchestrates the migration. It basically, once you create the service, we start the project. So what we do is, let me go ahead and pick the service. And I start a new migration project. And in the project, let's say Ignite Cloud. And you can pick different sources. So in this initial version, we have these sources. It's still a preview release. In the future iterations, you will see more options. So since I'm moving my on-premise database to cloud, I'm picking SQL Server as my source. And target again, multiple different targets. Since we'll be moving to a virtual machine, I'm picking Azure Virtual Machine, and start my project. And you will see that in 4 steps, I'll be done with the migration. And as you can see here, the first thing is I need to give my target instance. So I've already provisioned a VM, and I'll give the details of that VM. Let me quickly grab the... And you can pick any authentication. I'll leave it at Windows authentication. So what it does now is it connects to the target, ensures everything is it's capable of receiving the upgrade. So now it's verified the target. Now I give the source. It's a different number IP. In this step, once I give the credential, it connects to the source, and it tells me all the databases that are available on my source, which I can pick for moving. Done. So, okay, for the demo, I'm just going to pick this power consumption app, and I will show you. Actually, before I do that, just to make sure that I'm not cheating, here I'm connected to my target, and you can see that there are no databases here. So we are going to move the power consumption database from my source to this target instance. So I selected the source database. Now it's asking me the backup location. What the service has to do is it'll connect to your source, back up your database, and then take the backup and then restore it to the target. So I'm going to give a share on my source, which has permissions to write the backup. And for target, it also asks me, where do you want me to restore the database files to? The default it picks is F drive. You can actually pick a different drive if you want. Also, you can change the database name and settings, just like you would in the restore dialog in SQL Server. I'm going to leave all that as is for now. So it's basically validating that it's able to connect to that share and get the credentials. And here's a summary. As you can see, I have target server, step 2, target version, source server, source version, and 1 step. So straightforward so far, just have to specify some basic settings. And then all I have to do is hit run migration, and then the migration is running here. You can see that it's already finished backup, it's fast and it's restoring. We will create multiple threads so that the backup is striped and it's fast, and same thing for the restore also. So give it a couple of seconds. It's okay, it's done. Now let's go back to my target machine. Let me refresh this. Okay, the database is there. Now, the next step is application, right? How do you easily move it? It's very simple. So I have an application. Let me see if it works over this internet connection. Yeah. The share? Yes. So the question is, do I have to create the logins previously? Yes, because we have to authenticate the user. So because it's running in the backup and restore happens in the context of the SQL Server account, but for the DMS service to connect to the source and target, it needs to make sure it can connect, and it also needs to make sure the account has write permissions to the share for the source and read permissions to the share for the target. So I have this console application. This is also available in the SQL Server GitHub. It's like an IoT app. It inserts a lot of, think of it like sensor data repeatedly. And so I have a config file, which I have. Now I change the connection string to point to my target, to the power consumption database. So before I run this, let's take a snapshot of the row count. So it has 45,062 rows. Now I've changed the connection string. Let me hit start. So it will take a few seconds because this is connecting from my to the cloud. So this might take some few seconds to get through, and then you'll start see, yep, now the data is flowing in. You can see the rows per second and over here that are being sent as inserts and updates. And pretty soon, if we switch back to the database, it takes a few seconds to come in, and then just give it a couple of seconds and it should be there. Yep, you can see that it went up. So it's very easy. I mean, all I had was to change the connection string and a simple 4-step in database migration service, and you're up in the cloud, and very quick. So that's a good way to bring the database in the cloud. And the last step is we looked at the security center, we looked at other best practices, and I want to introduce a new service which is still in preview and it'll be coming later. So how do you manage an enterprise backup solution in the cloud, and how do you protect your data the same way you do on premise? So today, if you have to back up, you have to individually create storage accounts, as I mentioned, and then back it up to the cloud, and you log into the portal. So the backup service is very straightforward. You specify a storage vault. You pick all the SQL Server instances that you want to back up, so it does a discovery of it, and then it gives you all the databases. And then you can configure a backup policy, like full backup, log backups and differential backups on your schedule, and the service will take care of backing up the entire set of VMs. The main advantages is today on your on-prem infrastructure, you would have to create your own backup server, and then you have to manage that server. And if you did not have the backup infrastructure, you have to manually write scripts for each individual instances and databases. And there is no advantages of things like long-term retention policy, and no built-in alerting or reporting. So with this, we get you all this natively. In addition, we will give you point-in-time restore. The backup solution is always on aware, meaning if you have an always-on replica, and based on your always-on settings, if you say prefer secondary for backups, it will do the same thing even in the VMs. It will back up your database on the secondary replica without impacting your primary workload. And we provide at this time, we have RPO guarantee of 15 minutes because that's the frequency of log backups, but you can do point-in-time restore. And the UI actually makes it very intuitive and very easy to use. Let me quickly show you how that works. Okay, so this service is in preview. In the slide, I had an email address. If you're interested, definitely email that address to get more answered. The first thing is I pick a recovery service vault. So recovery service vault is something you can just create from here. It's basically asking where are you going to store your backups, and it'll ask you your storage account. It's very simple. So once I pick my recovery service vault, this is my overview pane where you see all the alerts and other information. But the first thing is I need to create a backup policy for my environment. I do that by coming here and clicking on plus backup. Now it'll ask me where is my workload running. So you can actually even do on-premise, but not for SQL Server, but for other workloads. So I'm going to pick Azure since my server is an Azure VM. And this is customized even for SQL Server, as I mentioned. So you can pick SQL Server in Azure VM as your location where your backups are. So the next step is to start discovery. So for your subscription or a group of subscriptions, if you hit Start Discovery, it'll go and gather all the SQL Server instances and also discover all the databases that are in that instances which are currently not protected. So in this example, so I'm going to pick this instance and then hit Discover DBs. So it basically deploys an agent on that VM and uses that for discovery. One point I want to make is this uses a service account that needs to be part of the VM. For gallery images, the service account is already part of the VM. If you're bringing your own custom images, you need to add the service account to your VM so that it has permissions to SQL Server. So while that is, so it is still deploying the agent, as you can see. Meanwhile, I have already done registering of some servers, and you can see these are all ready, and this one which I just did is still in progress. So the next step is, once you have discovered, you basically go define a backup policy. So let's go click on backup. Now it's going to, for all the instances which are ready, it's going to show me which ones are ready for backup. So let's just pick. So this one is a always on instance. I have a couple of databases I can back up there. So I'm going to pick that. And then I have a different instance. You can see that I can also pick system databases. So I'll pick all of these. I'll click OK. And here is where you define your backup policy itself. So I can say create no ignite. So I can define a full backup policy, differential backup policy, and log backup. You can have a separate policy for each, or you can combine all of them into a single policy. So it has all the details that you would expect even in SQL Server Management Studio, including long-term retention, as you can see here. I'm going to skip all this and just hit OK. And you also have compression to save on disk space. So I'll do enable. And this will basically, next thing is if you go to the jobs, you can see all the different jobs that are running in progress right now. You can see that configure backup is still running. The registration which I had asked to do for discovery, that is already finished. So now I can also back up databases from there. And once this finishes, this is only creating the jobs. This is not actually doing the backup, because your backup will still be done only based on the policy you defined. If you say only do backup once a week, only then it will happen. But it will also allow you to do ad hoc backups. I'll show you that as an example. So actually, let's go back. So if you go to the protected items section, if I hit backup items, so this shows in my VM all the databases which have a policy defined. So I can actually pick any database. You can see that you can do a backup now. So if you want to do an ad hoc backup, you can do that. You can actually even do a restore. And if you want to do another beauty is it gives you a restore plan. So if you were to restore now, it gives you a window of, from the backup, how much you can restore in terms of point in time. So all the green means we have log data since till this point in time. So you can actually restore to any point till this time. And if you have a combination of full backups, differential backups, and log backups, this service will automatically pick the right combination, so it will only need the minimum number of backups to actually do the restore. So let's go back. Yeah, so let me also show you the restore piece. Let's pick this shopping. And you can restore to a different instance too. So in this case, I'm restoring to a different instance and I backed it up. And you can specify what name you want. For safety, I'm adding the date and timestamp so it doesn't overwrite an existing database. But here an option is there to put an alternate name. If you really want to overwrite, you can check the overwrite button. And then hit OK. It'll ask me till what point in time I need to restore, like I mentioned. I can pick a date and time. So let's leave the default. And if I want to leave it unoperational and leave it disabled with no recovery, or enabled with no recovery, or disable it so that it recovers the database. And you can specify a different file location if your target server does not have the same drive letters. So that's it. Now if I go back to the jobs, you can see the restore is in progress to a different instance. Actually, my configure backup policy also finished, so these servers will also start backing up as per my schedule. So that's the new service. It'll be coming soon. And as I mentioned, if you are interested in this or want to provide feedback, definitely send an email to the Ask Azure backup team at Microsoft.com, and they will get in touch with you. Yes, question?
How about retention? All backup files because of storage limitation?
Yeah, so this one gives you long-term retention. So you can specify the number of days. So we will guarantee that the backups are available for that much days.
The other question is, why would I pick this rather than using the regular SQL agent job?
The question is, why would you pick this? So SQL agent is still instance-based. Let's say you have, just for numbers, 100 VMs, and each VM has 10 databases. So 1,000 VMs. You still need an enterprise-level backup strategy, unless you have enough time to go write and deploy and monitor scripts at every instance for every database. And this also has a monitoring dashboard, as you saw, so you can see everything at a glance at a data center view if you are moving your entire data center to the, yep, question. Are you asking if you have a way to back up with replication? So this does not have it yet. That's good feedback. But you can actually write a PowerShell script for that and have it run across all your instances. But let me wrap up, and I'll be available for any questions. So in terms of customers, we have tons of big customers. I mean, this is just a small list who have been using SQL Server for enterprise workloads successfully on Azure VMs. Because a lot of customers were not able to directly move to Azure DB because of limitations in terms of what it provides. Because Azure VMs is just like an on-premise SQL Server, but it is ready for enterprise workloads, as you saw from some of the performance demos, and as well as the new SKUs like the M series, which provide you even better IOPS and throughput. And you can definitely move there and leverage some of the nice features that Azure provides as an infrastructure itself. So, and I have tons of links here. Definitely, please take a look at this, and I will be available the rest of the day at the booth, Microsoft booth in the Expo Hall, if you have any questions. Feel free to fill the eval form and provide feedback. That'll be really useful. And if you have any further questions, want to reach my team, you can reach us to the Twitter handle that I shared earlier in the deck. And with that, that's all I have today. And thanks for coming, and enjoy the rest of your conference.